So now remember, I did part 1 for this example 1 for multiple regression. Now I'm going to go and talk about what the graphs are. So I did that 4 in 1 plot. So let me explain what everything is. All right. So this normal probability plot, you've seen this before kind of. Remember when we did normality? So what I'm looking for is these blue dots to be along this, red line. And as you see, some of the dots are not completely on it. So that's telling me that there might be some issues with my data. And again, this is the residuals. And remember, the residual is the distance from the actual point to the line. So I'm seeing that some of the data is not fitting the line like it should. Okay. So this one down here is a histogram of the residuals, and it's showing me how I have some large and small residuals. So like here I have a frequency of 6, which is -1 residual. So remember, that's that distance from the line to the actual point. And I do have some positive residuals over here. Okay. The versus fit graph at the top, this needs to be more scattered, and it's looking like there's 2 very defined groups going on here, where it needs to be very randomized, okay? And the versus order can be used, but we're not going to go over it, so don't worry about that, okay? So residuals versus the concentration. Remember, this was the formaldehyde concentrations. So the graph should have the residual scatter and not to have a shape to it. And this looks pretty scattered. I can't make any patterns out of it. So for the residuals versus the ratio, this again shouldn't have any shape to it. But this graph doesn't really look scattered. It actually looks like it's got a curve to it, and there's maybe some stuff going on because there looks like there's distinct groups going on. So I need to look at that. Okay. Residuals versus temps. Again, this should be scattered. It looks pretty scattered. I mean, I have things are going on all over it. And then residuals versus time. This one looks pretty scattered. And you're probably wondering, well, what was so different about this one that I need to look at? There looks like there's something going on here. There's very distinct groups. There's nothing here and nothing here. But if I look at the other ones, they're a little bit more scattered out. Okay. So what does everything that we have mean? So we have an analysis of variance, which is, remember, I'm looking at all the different means of the groups. So for my overall model of regression, my p-value is 0. My p-value for concentration is 0.022. For ratio is 0.00. For temperature, it's 0.27. And for time, it's 0.094. Okay, that's what I'm looking at. I'm looking at these end p-values. And again, if I go back to Minitab, they're right here. They're lining up pretty good. So time, it's pretty high p-value. I need to look at that and see what's going on. Okay, so let's keep going. So remember, I don't know if we talked about, I think we did talk about this in linear regression. Anytime you run a regression, you run an ANOVA. So the overall model had a p-value of 0, which is great. So that means something's going on. Okay, oops, didn't mean to do that. All right, so then again, so the next part is my model summary, and I'm going to go look at this. So my model summary is right here. So it's showing my R-squared value of 72.92. So again, think about what R-square meant before. So there's some stuff going on there. I'm going to look at the 62.81 just to be conservative. So 62.81% of y could be explained by x. So just remember that from the linear regression. Okay. Okay, so again, the model summary looks at the standard deviation of the residuals, the coefficient of determination. We want to have a small s and a large adjusted r-squared. So since our s is 0.8118, and the r-squared adjusted is 62.8, we have an okay model. One of the x values could be causing the model to have issues. Yeah, I mean, it's okay, but I would like it better. Right. So now I'm going to look at my p-values, and again here, everything, if I'm looking at 0.05 level of significance, all of these would be significance. This time one would not be significant. Okay, so while the ANOVA table can help us determine significance of the model, we have to use the coefficients to provide significant tests for all of the variables in the model. When the p-values are lower than our level of significance, the results indicate that these variables, oops, spelled it wrong, have a significant effect on the y variable. Okay, so the variables that had p-values less than 0.05, concentration, ratio, and temperature. Okay. So these three variables have statistically significant effects on the wrinkle resistance. Okay, and how do I know that again? Here, concentration, ratio, and temperature, their p-values were lower. Okay. So another thing we need to look at are the VIFs, and what does VIFs mean? So basically, it's a way to measure the effect of multi-linearity among your X variables. Multi-linearity is a simple term to describe when two or more of your X variables in the regression model are highly correlated. So think about this. If I made a regression model for JHC students and I included birth year and age, those are going to have, because basically it's the same thing, they're highly correlated. So you can't do that. When you do a model, you need to make sure each variable is not correlated to another variable. And this is how you catch it with these VIFs. So again, you got to be careful when you're looking at stuff like that. So VIFs measure how much of the variance of the estimated regression coefficient increases if your X variables are correlated. More variation is bad news. We're looking for precise estimates. If the variance of the coefficient increases, our model's not going to be reliable. So basically, what's that mean? I want VIFs that are under 10. In this model, they're all 1, so that's great. That means that they're all independent. They're not dependent on each other, and I'm not measuring the same thing twice. Okay. You also were given the regression equation. So if I go back up here, it gives me the regression equation. So it gives me that y-intercept, and then it gives me concentration, ratio, temperature, and time. So basically, I could put a value in for concentration, ratio, temperature, and time, and it would give me the rating because I can predict what the rating's going to be. Okay. And then another thing it gave me, if I keep going down, is it gave me unusual observations. So something about observation 9, and if I go down here and look, I'm going to bring this up. Oops, come on. So it's looking here at observation 9. Oops, I didn't mean to touch it, where the rating is 4.8. Something's going on with that value. So I need to look at that, and it's a large residual. So again, the regression equation helps me make prediction about the y variable. Since you can use it, but you want to make sure you have a really good model. So that observation thing that I'm looking at, R is a large residual. So that tells me that there's a large residual in row 9. What you do with it is up to you. So I'm not telling you to delete it. I'm not telling you to do anything like that. You really need just to make sure that the data is valid. And it could have been a bad batch. It could have been data was keyed in incorrectly. But before you do anything into it, you need to investigate why that's existing. Okay. So the conclusion, the predictor's temperature, catalyst ratio, and formaldehyde concentration had p-values that were less than the level of significance. The results indicate these predictors have a statistically significant effect on wrinkle resistance. Even though the resistive graph for rate showed a curve in the data, the p-value showed statistical significance. Again, I'm using those p-values. To me, those are right now pretty important. The p-value for time is greater than 0.05, which indicates there's not enough evidence to conclude that time is related to the response. The chemist may want to refit the model without this predictor. Okay. And again, I've got to make this assumption that there should be independence of errors, which I did, and there's no multi-linearity, which there wasn't. There were some high residuals, but I'm going to keep them in. and the residuals seem to be approximately normally distributed. Again, they weren't great, and I'm going to tell you what I'm talking about again. So I'm looking at this. There were some values that didn't go off of it, and because I had a predictor that wasn't significant, I'm going to try it again by taking out that predictor.